Hello everyone, my name is Pranay Sharma. Welcome to Mentor. I'll be your lecturer for this term, and the topic that we'll be discussing today is arithmetic progressions. This is going to be session number 1 for class 10th. I'll be giving you an idea of what do we understand by sequence as well as series and how we can categorize something as arithmetic progression. So today we'll see its general term, and after that in coming sessions we'll be solving multiple questions based on summation as well as generalization, few word problems, how it is used effectively in day-to-day routine. So that is something that we'll be covering. All right. I hope my slides are visible. Roadmap is by the end of the session, we'll be able to define what do we call a sequence as well as how it is different from a series. All right. So whatsoever I'm not mentioning in the slides, I'll be telling verbally because the thing is that you cannot have everything on a single paper, right? Either you will be having a roadmap or a mind map, or you should be having another generalization. Now, second term that I would like to highlight here is general term of an arithmetic progression, right? That we'll see once we'll start exploring what sequence and what series is, and after that we'll be slowly moving to arithmetic progression. So let us get this started. Now consider these arrangements, right? These arrangements are definitely three different arrangements must be following uh, uh, some different rules, right? The rules may not be one in the same. If you consider the very first one, it is giving you some contextual clarity, and you will be easily able to figure out what exactly the pattern that we are having here, right? So we'll be doing this not in terms of mathematics, we'll be doing it in terms of reasoning, right? That you will be facing when you actually go for army entrance exam, or we have multi-folded exams in India, which is one of them is SSC, right? You will be also having this in CSET, which is for UPSC. That is the second paper, qualifying in nature. So this is something that you will be having. All right, 2, 4, 8, 16. If you observe the very first, I'll be terming this as sequence, right? Arrangement it is. All right. So if you look at the first arrangement, we know that except for the first element, that means except for this two, right? Let me use highlighter for this, or arrow will also work. Not exactly arrow. I'll be using the laser pen. Yeah. So if you can, see this, except for this particular thing, right? This two. This 4 is something that you get when you multiply this 2 by 2. All right. This 8, the third term, you will get when you multiply the previous term by 2. This you will get when you multiply this term by 2. So except for the first term, right, all the other terms, I'll be calling them as terms, right? These numbers are known as terms. Except for the first term, all the other terms are following a definite pattern, right? A definite pattern. And if you look at the second one, now see, pattern may be in multiplication, it may be in division, it may be addition, maybe subtraction, but few patterns are also related with the categorization of numbers, right? So if you actually have a look here, 2, 3, 5, 7, these are prime numbers, right? So what will be the next number? That is the question. Then, do you know what prime numbers are, right? Prime numbers are the numbers having 1 and their factors are 1 and the number itself, right? Those numbers are categorized under prime numbers category. Now, what do we understand by co-prime then? That is again a question that we'll see when we'll be discussing other sessions as well. Then look at this 1, 8, 27, 64. Now it is very difficult for us to judge whether to multiply or to divide, right? Obviously, it is not a case of division because division is nothing but subtraction. And here we are not seeing any sign of subtraction. So what exactly it is? It is obviously addition. That means we should be, somewhere thinking of multiplication because addition is multiplication is nothing but addition, right? So 1, 8, 27, and 64, if you can, have some clarity of this cube. So can I say this is 1 cube, this first term, second term is 2 ka cube. Okay, let me jump to whiteboard. We have whiteboard as well. Just a second, my complete screen is being shared. So let us jump to whiteboard. Yeah. Okay. So 1, 8, 27 by 64. This will be 1 cube. Cube is when you multiply something by itself 3 times, right? This number, 1 cube. This will be 2 cube. 2 into 2 into 2 is 3. This will be 3. 2 into 2 into 2 is 8. This will be 3 cube. 3 into 3 into 3 is 27. And this will be 4 cube. All right. So there must be some pattern. That is what the sole agenda is. So I think we have covered sufficient in terms of what we say arrangements. So this is an arrangement, except for the first term, all the other numbers are following some pattern, right? Either they are related with multiplication with first term, or they are related with division, addition, subtraction, right? Cubes, squares, square root. This is something that we'll consider when we are given with any situation as such. But as of now, this is an arrangement, and this type of arrangement is known as sequence. All right. So explanation is being given to you, but this is known as sequence. So we call these arrangements as sequences, and the numbers in the arrangements are terms. That is something that I have highlighted. You can also give them a denotation, which is A1, A2, A3. Let us consider an example. Okay, this we'll be considering this example. We have 1, 8, 27, and 64, right? What if I'll be calling this as A1? I'll be changing the marker. A2, A3, A4. It will be easy for us to give a variable name, right, to the numbers so that we can do other mathematics as well when we want to generalize something. We always give this variable name nomenclature when we want to generalize something. So I have denoted this with A1, this is A2, and this is A3. So this is nothing but a denotation, right? You can also replace this A1 with A only. Few people used to call this as A naught, but there is hardly any difference between A1 and A naught, right? And A. They all are coming under the same category. We don't further classify them. Fine, people. Let's move to our, yes. So these are terms, and as the arrangements are continuing infinitely, right? So we call the last term as nth term. N superscript th term, nth term. Few people also have this in a different pronunciation, nth term. So it is one in the same. It is denoted by an. All right. So it is a sequence containing n terms, a1, a2, a3, and it goes till an. This dots in between, they are representing that yes, this particular arrangement is going till n terms. All right. Now, if we add them, then this is nothing but a series. If you add all the terms of a sequence, then that will become series. Now, sir, we have a question, right? What question exactly do we have? Suppose 2, 4, 6, 8, and so on, right? We don't know its n term, but this is a sequence. If you are telling us that you are adding them, right? Let us not consider n term at this point in time. We'll only be considering the terms, right? 2, 4, 6, 8. Now, if you add them, then I'm calling them this. I'm calling this as series. Right? Fine, people. Are you with me on this? This is a series. It goes till let us say an. This is a series. Fine, people. Can we have negative also in between? Yes. Numbers can be negative, right? What if we have 1, -2, then we have +2, something like this. Let me formulate something for you guys, right? So that will give you a feel. Mm, except for the first term, right? All the other terms are having what? A common difference, which is -1, right? If you add -1 to it, it will become -2. If you add -1 to this, it will become -3. If you add -1 to this, right? Is it giving you -1? No. You should be writing here 0. right? But 0 won't serve any purpose as such. But still, this is just an hypothetical example for our consideration. Let us consider a different example. We should get this started with -1 only. -1, -2, -3, -4. Because I don't want you to go through with leading factor as 0. This you will not be finding because 0 will not give you any contextual clarity. That is why your books are not mentioning 0 as a leading term. Leading term means any term should not get started with 0. Because if it is getting started with 0, then it is very difficult for you to identify what type of pattern someone is following. However, this is also a pattern. This is nothing but the category of whole number, right? Addition of 1, so common difference comes out to be 1. This can also be classified as a sequence, but we usually avoid 0 in the leading vector. All right. So -1, -2, -3, -4. Yes, terms can be negative. If you add them, it will look like this. If you simplify it, it will be like this. So yes, negative can be there. All right, people. That is what my point of interest in this. Why I am highlighting this very well. All right. Now the question is, we need to write the first three terms of this sequence. So we are given with general term. General term means by using that term, you should be able to identify each and every term of the sequence, right? So this is a generalization of a sequence. When it is given, it is very easy to have an absolute value calculated related to the terms associated. Fine. So let us move to our whiteboard. A n is 3n plus 2. I'll be changing the marker. An is 3n plus 2. All right. So suppose if I wish to calculate the first term, I told you sequence goes like this, right? And so on. First term is a1. That means instead of this n, if I'll be substituting n as 1, it will be giving me the first term, which is nothing but 5. According to board mass, 3 into 1 is to be followed first, right? Second term, when we substitute n as 2, it will be 3, 2 plus 2. That is nothing but 6 plus 2, 8. If n is 3, then a3 can be calculated as 3, 3 plus 2, which is 9 plus 2, 11. So 5, 8, 11. These are the terms associated with the question asked. I hope this is clear. Now, so far we have discussed that yes, there must be some rule in order to have some sequence, right? That means be it following the rule of, let us say, prime numbers 1, 8, 27 and 64. But if suppose we have the difference between the terms as one and the same, then that will be coming under the category of common difference, and that is nothing but arithmetic progression. We used to call that as arithmetic progression. Considered this sequence, we'll be considering another sequences as well. 1, 4, 7, and 10, and so on. If you observe the common difference, that means the difference between the second term and the first term. A2 minus A1 is what? Plus 3. A3 minus A2 is again plus 3. A4 minus A3 is plus 3. So common difference is same. If common difference is same, then this type of sequence has a special name known as arithmetic progression. All right. Now, we can also have difference. Suppose we have started, our leading vector is 13. Leading vector means the first term. It is started with 13, and then we are subtracting 5 from it. So we'll get 8. Again, we are subtracting 5 from 8, we'll get 3. Then we'll subtract 5 from 3. So it will come in negative, -2, and so on. So in this sequence, we know that there is a common difference. In above sequence, there is a common difference more than a preceding term, right? This type of sequences are known as arithmetic progression. Fine, people? So this is what we wanted to cover, but I'll give you a clarity on this as well with the help of an example. And that example is going to be mathematically aligned. Let's consider another case. We'll be doing this with blue. Okay. A1 is the first term. A2 is the second term. A3 is the third term and A4 is the fourth term, and it goes till AN. All right. If you take first two terms, then A2 minus A1 will give you what? D. Rather than this, I should be referring this as CD, which is common difference. But we will be only writing this as D, small d, right? We will not be writing this as CD. If we take these two terms, so it will be A3 minus A2. Again, this is going to be D. If we take these two terms, then this will be A4 minus A3. Again, it will be coming out to be equivalent to D. All right. That means technically what I can say is the difference is going to be one and the same. So can I equate the terms now? That means I can write A2 minus A1. It should be equal to A3 minus A2. Should be equal to A4 minus A3. So suppose if any one parameter is not given to you, so you can use this relation as a precise relation in order to get anything calculated. Fine, people? This is nothing but common difference T. Okay. Now let us move to another thing, which is one. See, this is the simplest AP that we can have. Let us say it goes till 15. All right. So this represents first term. I'll be calling this as A1. This represents second term. I'll be calling this as A2. This is A3. This will be A4 and so on. So A2 is what? A1 plus D, right? Likewise, A3 is what? A2 plus D, which is nothing but A2 is what? A1 plus D. So that means A1 plus D. That is nothing but A1 plus 2D, right? A4 is what? A3 plus D, which is nothing but A1 plus 2D plus D. From here, I have derived this, right? This is nothing but A1 plus 3D. I hope this is clear, right? Likewise, what will be A5? A5 will be A4 plus D, because if you add common difference, then only you will get the next term. So it will be A1 plus 3D plus D. That is nothing but A1 plus 4D. So if you can observe the pattern, A2 is what? A1 plus D. A3 is what? A2 plus 2D, sorry, A1 plus 2D. A4 is what? A1 plus 3D. And A5 is what? A1 plus 4D. If you observe that if we have 2 here, right, then first term is common across, but the difference is getting multiplied with 1. If we have the third term, then for third term, the difference is getting multiplied with 2. For fourth term, the difference is getting multiplied with 3. Fifth term, the difference is getting multiplied with what? 4. So for nth term, A1 will remain the same. This difference will be getting multiplied with n minus 1d. Whatsoever the value of n that we have, it should come here. So this is nothing but a general term of an AP. Instead of A1, I told you at the very beginning, you can also write A. Or few authors can also mention this as A naught, but A is most commonly used. So we can further generalize this as A plus n minus 1d. That is nothing but a common term of AP, A nth term of AP. It can also be represented as T of n or A of n, which is nothing but A plus n minus 1t. Now let us move to our slides. Let us see what exactly do we have in slides. So that is it. That is what we are having. In case if you have any doubt, you can mention it. We'll be, trying to take the same in the next session. However, this was just an introduction session. We'll be having few more sessions for arithmetic progression and we'll be covering them one by one. So I hope you have enjoyed the session. Thank you so much for your valuable time. Thank you. Bye. Take care.